Hi everybody, in this quick video we're going to talk specifically about what do the words dominant and recessive mean. And the reason I'm doing a video on this is because these are highly misunderstood. In general, people tend to think of dominant as being more common or being somehow better for your health, or that they're going to become more common or something along those lines, but it doesn't mean any of the sort when it comes to genetics. In reality, I want you to remind you that for any particular gene, there are lots of different versions, and the word dominant, it refers to an allele that takes over the phenotype when we've got two different ones. So again, if you don't remember the term, heterozygous means an individual that has two different alleles for the same gene. Not two of the same, two different ones. And if those two are different and one of the alleles controls the overall characteristic, that allele is called dominant, the other one is called recessive. Now, to figure out which of the two alleles or which of the 20 alleles is dominant compared to any one of the other ones, we have to do something very specific. And to do so, what we need to do is cross or mate two individuals, both of whom are true breeding. And what that term means is they're effectively inbred or purebred for generation after generation after generation in that family or community or grouping. They've all had the same characteristic. So they only have one allele in that population. So let's just simplify and go through an example. So let's start as simple as we can with a simple white flower. And imagine that flower is coming from a long line of white flowered plants, nothing else in its ancestry anytime recently. And we're going to mate it with a purple flowering plant. And again, that purple flowering plant, for generation after generation, all of its ancestors, as far as they know they can go back, have all been purple or lavender flowering plants. When we look at their kids, in this example, let us imagine that all the kids end up looking exactly the same. Every single one of their offspring ends up looking lavender in terms of the flowers. Now, in this case, because we have two parents with different alleles, and they've got heterozygous offspring, and there's one allele that effectively seems to have won out. It's seen in the phenotype of the hybrids. In this case, lavender is the dominant allele, and the white allele is called recessive. Now, this is the simplest possible example, and when we have one dominant allele in this case, we tend to name that allele with the letter of the dominant characteristic. So we're going to choose L, because L stands for lavender here. And we use the capital letter to indicate the dominant allele, lowercase for the recessive. Now, this might look a little confusing because you might imagine, well, it's white. Why not use W? Well, we're going to stick with the same letter for that trait or that gene. So flower color here is controlled by a gene that we give the L letter. Capital for the dominant allele, lavender, lowercase for the recessive allele, in this case, white. Okay. Now, keep in mind, these were purebred or inbred flowering plants, so that's why they only have one type of allele, little L's or big L's. But when they passed on their genes to their offspring, all of these lavender kids got one big L from the parent on the right and one little L from the parent on the left, because they got one of each pair of homologous chromosomes in the gametes. Okay. That is the simplest possible example. Here's another example. In this case, you can see two different hands. And let's imagine there's a person on the left with hands that have 5 fingers, and on the right we have a person or an organism with extra fingers and toes. This is called polydactyly. And if you have one parent who comes from a long line of folks that only have 5 fingers and toes on each hand or foot, mating with somebody who is from a long line of people who have extra or partial extra fingers and toes, in general, what we find is all of the offspring have extra fingers and toes, all right, either partial or complete fingers and toes. This happens to be called polydactyly, and so in this case, that is the dominant allele. And the reason I give you this example is because we tend to think of the most common variety as dominant, and here it's not. Polydactyly is reasonably rare. Less than 1% of a population has that characteristic. but it is the dominant allele here. When you have two parents that have the different characteristics that are homozygous, the kids tend to be, in this case, polydactyl. So having 5 fingers is the recessive trait in this case, and if we put in the letters, remember, the dominant allele controls the letter that we choose, so this is going to be capital P, and then the recessive allele is going to be lowercase of the same letter. The kids get one of each homologous pair from each parent, so a capital P from the parent on the right, lowercase p from the parent on the left, end of story. Okay, one more example because things get a little bit crazy at times. This last example is going to be blood type. Now let's imagine we have one parent who is type A blood from a long line of people, an entire village of people where there's only type A blood. No other alleles are present in that population. And then another person from a population that is entirely B. No other alleles in that population. If they mate and have kids, what is a little bit strange in terms of what we've looked at so far is every single kid is going to have what's called type AB blood. They will have both of these characteristics at the same time, despite it being a single gene that we're talking about. Now, we can go into the details of what this means later. I just want you to see that in not every case is there one dominant allele. In fact, there can be different levels of dominance between 5, 10, 100 different alleles. So in this case, we could call these two equally dominant because they happen to be equally dominant to another allele. In this case, because they're equally dominant, we want to give them the same capital letter. And in this case, typically we've used a capital I, and we don't have to go into the details, but keep in mind, because they're equally dominant, we give them the same capital letter, and then we're going to use a superscript to indicate that they're different alleles, the A's versus the B's. Okay, hopefully that gives you an overview of where we're starting. Up next, we'll talk about probability.